Welcome to this explainer. Let's unpack the totally invisible architecture of a wireless signal. Ready?
So, how does an HD video actually reach your phone from miles away? No wires, no magic.
Back in the day, using one massive transmitter caused instant spectrum congestion. It jammed up fast.
The game changer? This cellular concept. We swapped that one giant transmitter for a bunch of low-power ones.
Basically, your city gets chopped into smaller puzzle pieces, or cells, each run by a local site.
Check this out. Neighboring hex grids use completely different frequency channels. It keeps wires from crossing, you know?
This clever trick is called frequency reuse. It minimizes interference and massively boosts how many users connect.
Radio waves naturally radiate in circles, sure, but engineers map networks using interlocking hexagons to prevent dead zones.
Okay, let's picture the physical journey of a single, completely unobstructed signal smooth sailing right. Well, engineers actually use the Fry's free space equation to predict exactly how strong that signal hits your phone.
Simply put, the power you get depends on the initial burst, antenna efficiency, wavelength, and distance.
The main takeaway here is that radio signals lose strength super fast the further they fly.
But look, we don't live in a void. We live in loud, messy cities full of obstacles. And these physical obstacles trigger three propagation mechanisms that totally mess with how your signal behaves.
First up, reflection. Your signal literally bounces right off large flat surfaces, like giant skyscrapers.
Next is diffraction. This actually lets signals bend around sharp architectural edges to magically reach you.
Finally, scattering. Tiny objects like raindrops or leaves scatter the signal's energy in a million different directions.
Now, in reality, all three of these happen at the exact same time. It's an absolute obstacle course. Because of all this bouncing and bending, multiple delayed copies of that same signal crash into your receiver. This chaos causes fading, wild, rapid fluctuations in signal strength happening in just milliseconds.
Fading scrambles frequencies and smears data bits. It's a massive, massive puzzle for network engineers.
So, to keep your call from dropping, mathematical models constantly work overtime to compensate for these physics hurdles.
It leaves us wondering, as our data hunger explodes, how will tomorrow's wireless tech outsmart physics itself?